Hey guys, so we are going to practice a little bit more on antiderivatives and integrals. Just as a reminder, some of the integral rules that we already knew. 1 over x dx, the integral of that guy is going to be the natural log of x plus c. And the integral of e to the x dx is e to the x plus c, because remember, e to the x, the derivative of e to the x is just e to the x. So the integral of e to the x is e to the x. So we want to find the indefinite integral. So on a, we have 4 over x dx. So the first thing we want to do is we want to factor out that constant that we have in front. So I'm going to bring that 4 out front, and then I still have my integral of 1 over x dx. All right, so now we know from this rule right here that the integral of 1 over x is the natural log of x. And we also know that when I take the integral of something and I have a constant out front, I just multiply that constant by whatever my integral is afterwards. So I know the integral of 1 over x is the natural log of x. And then that 4 just drops down with me and multiplies my natural log by 4. And then at the very end of every integral or indefinite integral, I have to make sure that I put a plus c there at the end. Oh, that's not very spaced out. Let's try that again. Plus c. All right. So our first step over here was to factor out my constant. Over here on b, that's going to be the same thing. So I have e to the t over 2 dt. So that means I'm going to factor out that over 2. So over 2, that's the same thing as 1/2. So I'm going to bring a 1/2 out front of that integral. And then I just have e to the t dt. So the integral of e to the t is just e to the t. So I just change whichever variable I'm using there. So just e to the t. Just like before, my constant just dropped down with me. This time my constant is going to just drop down with me. So I have a 1/2 e to the t. And after every indefinite integral, I need to have a plus c. Okay, let's keep practicing. So on this one, we have x squared plus 1 and then squared. So we don't really have any rules yet to deal with this. So here is my advice. When you have something like this, it's really easy to multiply out. Go ahead and just multiply it out. So down here at the bottom of my page, I'm going to go ahead and do a little scratch work of multiplying out x squared plus 1 squared. So here we go. X squared plus 1. And I need to multiply that by x squared plus 1. All right. Now I've got x to the 4th plus 2x squared plus 1. All right, so when we multiply this guy out, this is what we end up with down here. X to the 4th plus 2x squared plus 1. So this we do know how to take the integral of. This seems a little messy. So if it's easier to multiply everything out and it's quick, just multiply everything out. So we are now going to look at the integral of x to the 4th plus 2x squared plus 1 dx. All right. So now when we go through and we find the antiderivatives of these guys, remember when we do the antiderivative, we have to add 1 to the power and then divide by the new power. So x to the 4th, I'm going to add 1 to the power, so now I have x to the 5th over my new power, so that's 5, plus, knock it off. Then I have 2x squared, so I'm going to take that 2x. I'm going to add 1 to the power, so that'll be 3. And then I divide by my new power of 3. And there's nothing really to simplify there, so we're good to go. And then the integral of 1. So if we think backwards, what did we have to take the derivative of to get 1? So if you think about it, the derivative of 2x is 2, so the derivative of 1x is 1. So that meant that if I take the integral of 1, that then has to be x, right? Because we're going backwards to undo differentiation. So that'll be x. And then at the end of each of our integrals, indefinite integrals, we need to make sure that we have a c there on the end. So over on D, I would not go through and try to, okay, so this is over x, so it has something to do with natural log. I wouldn't really go that route quite yet. What I would do is go through and simplify this in a way that we know that we can. That's maybe a little bit more simple than some of the other ways we could attack it. So this whole polynomial, 3x squared plus 2x plus 1, that's all being divided by x. So if we wanted to go through and simplify this, we can go through and divide each of these terms by x to rewrite it. So let's go ahead and do that. So now we're going to be looking at the integral of, all right, so 3x squared divided by x just leaves me with 3x plus 2x divided by x leaves me with 2 plus, and then 1 divided by x is just 1 over x. All right. So now we're going to go through and take the antiderivative or the integral. So on 3x, I'm going to take 3x, I'm going to add 1 to the power, so now it's squared, and then I divide by the new power, so that's 2. Sorry, Peanut's being really squirrely over there and playing and romping around, and I'm sorry if she's being plus, just a second ago when we talked about how the derivative of, the integral of 1 is x. So the integral of 2 is 2x plus. So now I have a 1 over x. So I can't really add 1 to the power and divide by the new power because then I would have x to the 0 power divided by 0, and we can't divide by 0. So we have to think about what is the integral of 1 over x. That's natural log. Plus the natural log of x. And at the end of every indefinite integral, we need to have a plus c. Okay, let's get a few more. So, knowing how things simplify is going to make your life a lot easier. Don't just immediately go into most problems trying to just straight away take the integral of it. Going through and simplifying it is going to make your life a whole heck of a lot easier. So one thing that you might recognize right now is natural log and e. Natural log and e cancel each other out. They undo each other, right? They're inverse operations. So when natural log and e cancel each other out, all we're left with there is just the integral of 2t minus 1 dt. And 2t minus 1, that's not too bad to take the integral of. So here we go. I'm going to take 2t, add 1 to the power, so now he's squared. And then I divide by the new power, which was 2, minus. And then just a minute ago, we knew that the integral of 1 was whatever that variable is there. Since my variable is t, this is going to be minus t plus c. Now, honestly, it hurts my heart. You don't have to go through and simplify. If you're going to have to use the integral for something, I would absolutely simplify. But the 2t squared over 2, it hurts too much to keep it like that. I'm going to simplify it. So now we have t squared minus t plus c. Okay. Over here on f, we want to work this guy out the same way that we've done the other ones. Simplify first. So what I think is going to be helpful is to pull out that 2 at the bottom first. So you can take that out as a 1/2. So we have 1/2. And now I have the integral of e to the t plus 1 dt. Oh, that's not a t, that's an x. Plus 1 dx. There we go. Okay, so now we can go through and take the integrals of both of these, and then we can distribute that 1/2 through if you want to, or don't, whatever feels good. So I'm going to keep that 1/2 out front. The integral of e to the x is just e to the x. We noticed a second ago that the integral of 1 is just going to be whatever the variable is, so t or x. So the integral of 1 over here is x. And then we'll have a plus c there at the end. Now, let's try a really beefy one. It'll be okay. It just takes a little bit of organization, taking a deep breath, and going through it. You'll be fine, don't worry. So we're going to take the integral of x squared plus x plus 1, all of that divided by the square root of x dx. So that looks freaking terrible, but here's my advice. Go through and rewrite the exponents. So instead of having the square root of x, rewrite that as x to the 1/2 power. So now, remember, this guy, since it's dividing this entire polynomial, is going to divide each one of those individually. So I have x squared over x to the 1/2 plus x over x to the 1/2 plus 1 over x to the 1/2. dx. So now where do we go from here? So we can simplify, since these guys have the same bases, we can rewrite the exponents. So what do we do when we divide our bases? What do our exponents do? So if you can't quite remember how that works, here's what I do. I make up a problem. So if I had like x to the fifth and I was dividing that by x cubed, well, I have 5 x's on top and 3 on the bottom. So 3 of them cancel out. So I'm just left with 2 up there on top. So what did I have to do with 5 and 3 to get 2? Subtract. So that's the rule over here that I'm going to have to do. So over here, when I have x squared divided by x to the 1/2, that means I'm going to have to take 2 minus a half, so that's 1/2 or 3/2. So that's the same thing as x to the 3/2 plus. Over here, since no exponent is there, that's really a 1. So x to the first divided by x to the 1/2, I need to subtract my exponents. 1 minus a half is a half. So now I have x to the 1/2 power plus. And now over here, x to the 1/2 power is just on the bottom. So remember, when we have anything on the bottom, that just needs to be moved up to the top, and now he's negative. So that's x to the negative 1/2, and we will take the integral of all of that dx. So I know that the first 3 steps in all of this was just us going through and simplifying things, but it will make our lives a whole heck of a lot easier down here. So remember, what we're supposed to do is add 1 to the power and divide by the new power. So here we go. I have x. 3/2 plus 2/2, which is 1, is 5/2. So I have x to the 5/2 over 5/2 plus x to the 1/2. All right, so I got 1/2. I'll add 2/2 to it. So 1/2 plus 1 is 3/2. So now I have x to the 3/2 divided by 3/2 plus x to the negative 1/2. Negative 1/2 plus 1 is positive 1/2. So now I have x to the positive 1/2 power divided by 1/2. And then at the end, I need to have that plus c. So you could leave it like that, but honestly, it breaks my heart. So remember, to divide by a fraction, I need to multiply by the reciprocal. So I'm going to be multiplying by the reciprocal on each of these. So I'm going to end up with 2x to the 5/2 over 5 plus 2x to the 3/2 over 3. Ow! Peanut. Plus 2x to the 1/2. Let's see. All right, that's cleaner and more beautiful. More happy with that. All right, so those are things you already knew how to do, even if it's just a little messy and a little bit long. We know how to do that. We just need to keep ourselves organized and have a little bit of perseverance. Let's learn a couple of new rules to help us find other antiderivatives. So, do you remember the chain rule? Chain rule was when you were taking the derivative and you had, oh, hang on. Sorry, my computer froze. Where am I? Okay. Chain rule. That's what I was talking about. Cool. So chain rule, remember that was when we took the derivative of something and we had to multiply by the derivative of the inside function. It was a function inside of a function. We're going to be dealing with the same thing. So when we had, let me switch this. When we had, why are you having so much trouble focusing? I'll figure out in a minute. Okay, so when we were using the chain rule, we had a function inside of a function, we multiplied by the derivative of the inside function, right? So we're actually going to do the opposite now of that chain rule by dividing by whatever the integral on the inside there is. There we go, it focused a little bit better. So if we have something linear in here, so ax plus b to the n power dx, I go ahead and I add 1 to the power and divide by the new power just like I did before, but then I'm also going to multiply by 1 over a, so right here. So instead of multiplying by the derivative, I'm dividing by the derivative to undo that chain rule. It's kind of like an opposite chain rule. Same idea over here on e to the ax plus b. So if you notice right here, I have stuff on my x. So the derivative of e to the x is just e to the x, so that function stays the same. But then I multiply by 1 over a, so I divide by the derivative of the inside. Same thing over here when I have 1 over something linear. Notice I keep saying something linear, something linear. What I mean by that is that this is just a plain old x. Ax plus b. It's not something squared, it's not something cubed, it's not something crazy like that. It's just a plain old x in there. And that's what's happening with each of these. So in case you're like, why does she keep saying linear? What does she mean by that? That's what I mean. So when I have 1 over something linear, well, 1 over x, the integral of that is natural log, so I'm going to have natural log of that stuff, but still I'm going to have that 1 over a out front. So instead of multiplying by the derivative when we're taking the derivative, now when we're going backwards, we're going to divide by the derivative since we're taking the integral. So let's take a look at this first guy. So we have 3x plus 1 all to the 4th power. So the first thing we want to do is we want to pretend like the inside of that is just x. So we want to think of this as taking what is the integral of x to the 4th. So we need to add 1 to the power and divide by the new power. So now I'm going to have something to the 5th all over 5. So I'm going to have something to the 5th all over 5, right? And that something is whatever is inside of those parentheses. 3x plus 1. And then I need to multiply by 1 over the derivative of that inside. The derivative of this inside is 3. Or if you wanted to think about it in terms of this formula, 3 is, wait, where am I? Over here. 3 is a. On this guy, 3 is a. So I'm going to have to multiply by 1 over 3. And then remember at the end of that, I need to have a plus c. It might not bother you, but it bothers me. I'm going to go ahead and multiply these two fractions together. Remember, when you multiply fractions, you just need to multiply straight across. 1 times 3x plus 1 to the 5th is 3x plus 1 to the 5th over 3 times 5 is 15. And then we need a plus c there at the end. All right. over here, we're going to take the integral of e to the 2x plus 5. So first we're going to look at the outside. What is the integral of plain old e to the x? The integral of e to the x is e to the x. I'm going to have to keep e. And then that exponent won't change. Plus 5. Now, since I have something other than just plain old x in there, I need to account for that. So I need to multiply by 1 over that guy in front of x. So I'm going to have to multiply by 1 over 2. And then at the end of every indefinite integral, I need a plus c. So now we've got 3 over 4x minus 2. So the first thing we want to do is pop out that 3 to get it looking like some of the other formulas that we had. So that's a constant that's just being multiplied by him. So I'm going to pull that 3 out front. And now I have the integral of 1 over 4x minus 2 dx. So if we go through and we think about 1 over x, what's the integral of 1 over x? The integral of 1 over x is natural log. So right now I have 3 times. And then we knew this guy was going to be natural log of whatever was in the denominator of that fraction, 4x minus 2. There we go. Okay. So, right here, 4 is my a value, right? So since we have something else in there other than just plain old x, we need to account for that chain rule. So I need to divide by 4. So I'll have 1 over 4 right there. And then remember, at the end of everything, we need to have a plus c on indefinite integrals. So 3 times 1/4 might not bother you. It bothers me. I'm going to rewrite that as 3/4 natural log of 4x minus 2 plus c. Okay, now we've got 1 over 6x plus 3 to the 4th power. So what I would do is I would rewrite that, since it's to the 4th power, or in the denominator, I would rewrite that as 6x plus 3 to the negative 4th power. So let's start there. The next good thing to do is to ignore the inside and just look at the negative 4th. So x to the negative 4th, what would we have to do with that? Add 1 to the power, divide by the new power. So that's what we're going to do right now. Add 1 to the power, now it's negative 3, divide by the new power. Oopsies, that's a silly looking line. So that's negative 3. And then whatever was inside of there goes inside of my parentheses again. And since I have a value here on x, I need to multiply by 1 over that value. And then after I take an indefinite integral, I need to make sure that I have a plus c at the end. So, once again, it bugs me. I want to simplify it. I'm going to multiply straight across. So I'm just going to end up with 6x plus 3 to the negative 3rd over 6 times negative 3 is negative 18. Plus c there at the end. You can simplify and move it around in different ways if it makes you happy. Whatever floats your boat. Okay, one last challenge one. It'll be fun. Oh! You all right there, kitten? Thanks. Okay, So here we go. First thing we want to do is break these two things up. So we have an e to the 4x and we have a 4 over 3x minus 5. So we're going to split that up into their own integrals. So I'm going to do the integral of e to the 4x plus I'm going to have the integral of 4 over 3x minus 5. So let's first look at the integral. Oh, I forgot my dx is on there. dx. There we go. So my integral of e to the 4x. So the integral of just plain old e to the x is e to the x. Now, since it's something other than just plain old x in there, I need to multiply by 1 over that value in front of my x. So I need to multiply by 1 over 4. Plus. Now remember earlier we popped that 4 out front, right? Or whatever was in my numerator, we pop it out front. Now I have 1 over 3x minus 5. Well, 1 over x, the integral of that is natural log. So I'm going to have natural log of the stuff that's on the inside. And then I need to multiply by 1 over my value in front of x. So I need to multiply by 1 over 3. And at the end of every indefinite integral, I need to have a plus c. So, oh gosh, why is it hard to see? Why is it hard to see all of a sudden? I don't like that it keeps adjusting. I'm so sorry. We'll want to clean it up a little bit, or at least I do. I'm going to rewrite e to the 4x times 1/4. I'm going to keep that as, I'm going to rewrite that as e to the 4x over 4 plus, and then right here 4 over 1, and then times 1/3 gives me 4/3 natural log of 3x minus 5 plus c. Ooh, peanut took off. Okay, so I hope that this made sense. We will practice some of this stuff tomorrow. I'm supposed to keep it to about half an hour, and I have a feeling I went a little bit over. So tomorrow, look forward to some practice. So have a great day, you guys. Bye-bye.